Welcome back. In this video, we're going to talk about mixture and solution word problems and extend our application and understanding and use of percents. So our goal here is essentially to have more application of percent concepts and an introduction to charts that assist in determining equations and solving word problems. So we're going to start using charts to help us formulate our equation and determine our unknown, which will help us solve our word problems. Well, let us begin by just looking at some basic concepts and skills that you'll need to have. Simple word problem, the sum of two numbers is 25. If one number is y, write the other number in terms of y. Well, if our two numbers would be like x plus y is 25, right? One number was y, so write the other number in terms of y. Well, that means our goal is to have our other number of terms of y will be x equals something, and that something will have a y in it. So the other number is x, and if we want that in terms of y, we would subtract y from both sides, and we get x equals 25 minus y. So our answer to this question is 25 minus y is how we express the other number. So y is one number, the other number is 25 minus y, or x is 25 minus y. And that's our total minus the one number that we know. Number two, if x milliliters of acid is added to 300 milliliters of water, what's the total volume of solution? Well, we have 300, we're adding some x, well, that's our total volume. 300 plus x is our total. So adding is a little bit easier. Next sample problem. If the total weight of a mixture is 8 kilograms and part of the mixture weighs x kilograms, then the other part must weigh what? Well, that's a lot like problem number 1. We had a total of 25. Okay, one number is y, the other number is our total minus y. In this case, our total is 8. One number is x, then the other number must be 8 minus x. And notice that's not the same as x minus 8. Okay? 8 minus x means we're starting with 8 and we're subtracting some amount x. X minus 8 means we have some number x, some amount, and we're subtracting 8. It's very different, especially if we decide that it's 10. We can do 10 minus 8 with a quantity and get 2, we'll have some left over. But if we have 8, we can't subtract 10. That's not the same as 8 minus 10. So be careful with those. And this concept is so important that we have 3 problems that deal with it. In a collection of 50 dimes and quarters, there are q quarters, then there are how many dimes? Well, we have a total in our collection of 50. Some of them are quarters, the rest are dimes. That would be 50 minus q would be the number of dimes. Okay, so that's our total minus the number of quarters gives us the number left over, the number of dimes. So 50 minus q, 8 minus x, 25 minus y. Our total minus our unknown is the other thing. And we're going to use charts in this chapter and throughout the textbook, throughout the year, to help determine equations for mixture and solution problems. And the charts are a lot like Microsoft Excel spreadsheets or Battleship or the grid on a map, where it's divided into columns and rows. And our columns, like Microsoft Excel, the columns are letters A, B, C, and D, and the rows are numbers. Row 1, row 2, row 3, row 4. And of course, where a column and a row meet is a cell, so this would be B3, where column B and row 3 meet. Okay, just like in Battleship. But now we've got a chart. We'll also see this in Microsoft Excel. And in our charts, generally, we are going to multiply across the chart. So we might multiply B1 times C1, and that will equal D. And we will add down our charts. So multiply across, add down. So if we have something in B2 and something in C2, we multiply those together, and that will be what goes in cell D2. Same thing, B3 times C3 will equal what goes in to cell D3. And it may be the same here in D4. This is a little different because we can add down and get this, but we can also multiply across and get what's in D4. So let's take a look at some problems. The instructions are as follows. Identify the variable, set up an equation in one variable, and solve and answer the question. And you can use the chart to assist you in identifying your variable and setting your equation. So the first sample problem, a grocer makes a breakfast cereal by mixing oat cereal costing $2 per kilogram with dried fruits costing $9 per kilogram. How many kilograms of each are needed to make 60 kilograms of cereal to sell at $3.75 per kilogram? Well, our chart generally is going to be quantity times a price or a percent equals sum total. And we've got a couple items. We'll put the items in A1, or pardon me, A2 or A3. So item 1 in our case will be the oats. He's making a cereal. We're going to have the oat cereal is one of our items. So that just helps you keep things straight. So this row will deal with the oat cereal. And this row will deal with the fruit. So this is our fruit. So our column, this is our price column. C is our price column, or percent. We're working with price here. So oat cereal, the price of the oat cereal was $2. And the fruit, every kilogram of fruit, was $9. So we're filling in our chart here. Now the total, or our mixture, that we're going to sell, he wants to sell 60 kilograms at $3.75 per kilogram. Well, how much oats? We don't know. And how much fruit? We don't know. But we do know this, 2 of these have to add up to 60. So just like we did earlier in the video, where we had a total minus our unknown was equal to the other, we can just set one of these as our unknown. So I'm going to let X equal the quantity of oat cereal, or the kilograms of oat cereal. So that must mean that the other, the fruit, must be 60 minus X, the total minus the other. And look, if I add down, X plus 60 minus X equals 60, that is a true statement. This column, we can't always add that down. That's not going to work out, because this is kind of weighted average. And you see here, if we're selling a mix valued at $3.75, our value skews towards $2. It's closer to 2 than it is to 9. So that means we're going to have more oat cereal than we are fruit. Okay, if this was 30 and 30, our mix, our price would be right in between. It would be $5.50. But that's not the case. So we know we're going to have more oat cereal than we are fruit in our mix, because our price skews toward the lower price. So let's finish out our chart. We multiply across our table. This particular cell is going to be the product of B2 and C2, so that's simply 2x. And this cell is 9 times 60 minus x. And this final column, it's not going to be the sum of the two. It's going to be the product of B4 times C4, or 60 times 3 3/4, or $3.75. So our unknown is the amount of cereal, not fruit, and our equation is sitting right here in the final column. This is our equation, that the total value of the cereal plus the total value of the fruit equals the total value of our mix. The price times quantity of the cereal plus the price times quantity of the fruit equals the price times quantity of the mix. So we can set up our equation. 2x plus 9 times 60 minus x equals 60 times 3 3/4, or $3.75. So we get 2x plus 9 times 60, 540 minus 9x equals 60 times 375, which is 225. And that'd be a negative 7x plus 540 equals 225. And simplifying this, I don't have my notes with me. You know what? I will let you finish this up and make sure you answer the question, which is, I want to know the amount of each. And you can bring that to me in class. Let's go on to another type of problem that students also find challenging. These are these chemistry problems, these solution problems. Maybe Mr. Cheney or Mr. Kaiser, one of the chemistry teachers, will ask you to do a problem like this. So the question is, how many liters of water must be added to 20 liters of a 24% acid solution to make a solution that is 8% acid? So we've got some water, we got a 24% acid solution, and we want to end up with 8% acid. So our items are going to be something that's 24% acid, and we have some water, and then our final solution will be 8% acid. So we're not going to work with percent or price here. We're going to work with percent. And of course, 24% acid is 0.24. And our final solution, 8%, is 0.08. And water is 0% acid. And we have in this problem, we start with 20 liters of 24% acid. And the question is, how much water needs to be added? So that's X. And so our final solution, adding down, right, we add down our chart, the sum of B2 and B3 is 20 plus X. We multiply across our chart to get this final column. So we're going to multiply quantity times percent, or quantity times price. I'm going to hold off on distributing here, or multiplying anyway. That's 0x, and we have 0.08 times 20 plus x. And notice I don't distribute right now, and I didn't even get rid of my decimals yet. So my unknown is the amount of water, And my equation is sitting right here in this, lost my spot, right here in this column. So my equation, 0.24 times 20 plus 0x, that's going to go away, equals 0.08 times 20 plus x. Since this is algebra class, we're going to multiply everything by 100 to get rid of our decimals. And we get 24 times 20 plus, okay, I'm going to get rid of the 0x, equals 8 times 20 plus x. So 24 times 20, 24 times 2 is 48, so 480 equals 160 plus 8x. I'm going to subtract 160 from both sides. And I'm going to get 320 equals 8x, dividing by 8, and x equals 40. So apparently I have added 40 liters of water at 0% acid. That'll get me to an 8% acid solution. So my final solution will be 60 liters. So there's a couple of nice sample problems on mixture and solution. You're working with percents here, so you can multiply by 100 eventually to get rid of those decimals. It looks like you've got a question that you need to answer, and I will see you in class.